Hi, I'm Molly. This is Physics 2212, Lab 1, Charged Tapes. So the purpose of this lab is to observe the interactions between two pieces of charged tape. We're going to determine the amount of charge on one of those pieces of tape and any excess or deficient electrons. So this is the model used. We're using two pieces of tape, A and B, to model a point charge separated by a distance d. Assumptions are that air resistance is negligible, that the tape is represented as a point charge, and that charge is at the center of the tape, and the tapes have the same amount of charge. So these are the physical principles used. We're going to use Coulomb's law and Newton's second law to determine the electric force. And then the other force acting on the tape is gravitational force. So both of those will be calculated, as those are both the forces acting on the tapes. This is the experimental setup. So we have our system as tape B. This is the tape that we're going to be observing. And then the surroundings are tape A and the Earth that are going to be acting on tape B. So the initial conditions are that all three pieces of tape are neutral, as we are going to induce charge on them later in the procedure. So the procedure is to charge the tapes by sticking them onto the base tape and removing them. This is going to add charge to those tapes, and then we're going to observe the interaction between those tapes, between themselves and between other objects. And then we're going to just suspend one tape between two objects of equal height and then hold the other tape under it and observe the movement of the tape. We're going to then measure this distance between the tapes and use that to calculate charge. So these are the observations. The interaction between the two tapes, they repelled each other, indicating that they have the same charge as like charges repel. When interacting with a neutral object, the hand of the book, they were attracted to it, and when interacting with the negative pen, they were attracted to the pen. This indicates that both of the U tapes are positively charged, and that there will be a loss of electrons, which we will further calculate. So these are the calculations. First, we have just the data from measuring the tape and the distance between them. Then we calculated the gravitational force using mass and acceleration, which we know. And then on the right, we can see the free body diagram showing that the electric force and the gravitational force are equal, as there is no acceleration of the tape. And we can set those equations equal to each other. We know all of the other values except for Q, so then we can solve for Q there. Then we are going to calculate electron deficiency using Q that we just calculated and the charge of an electron, which we know. And then this results in the number of electrons lost by a piece of tape. And then we can calculate the ratio, which is atoms per electron, by using the area of the tape and an area of an atom, dividing those, and we get the ratio of atoms per electron. And then this is the code that I set up to do essentially the same thing as our calculations using some set values and then some coded equations. And then the code resulted in the image on the left, which is similar to our free body diagram as expected, with the arrows being equal. And then the numerical results are similar as the ones in our calculations. So some comparisons. Our data does assume that the only existing forces are gravity and the electric force, but there could be other potential forces acting on the tapes affecting their behavior that we did not take into account. And then the model does assume that the charge of the tapes is exactly equal. However, there could be different charges based on our handling them, and the initial act of charging the tapes could have occurred slightly differently. And then the code does show numbers that are, in comparison, very close to the numbers that we calculated with slight differences. Those differences could be due to calculation or rounding errors or error in the code, but they're not as significant. And then for the discussion, if there was change in the charge, as if electrons had positive and protons had negative charge, there would be no change in the observations, as the principles would still be the same, that opposites attract and like charges repel. This would show the same results. However, there would be a loss of protons instead of electrons, but this would not affect the observations. And then why it's important to handle the charged tapes as little as possible. This is because our hands are neutral, and when the tapes interact with them, they will want to neutralize with our hands. So we want to avoid that as to not skew the charge to skew our results. So yeah, that is charged tapes.